All right, welcome to section 5, which is just one page on inverse functions. Inverse functions just flip the x and y. So typically we have the x here and the y here. This just flips them over top of the equation y equals x. So it's just a mirror image. So this would flip into this. It just mirrors each other essentially. So to find inverse functions, you literally just switch the input and the output. Here the output is h of x, the input is x. I'm just going to use x's and y's for simplicity, so I'm going to switch them. X goes over here, y goes over here, and now I'm just solving for y. So this is pure algebra. X plus 3 equals the cubed root of y. To get rid of a cubed root, I have to cube each side. And so y is equal to x plus 3 cubed. That's the inverse function. And so if I just want to write the correct notation, the inverse, so we just use a -1 to show the inverse is equal to that. So that's the notation we want in the end. All right, let's do this one. We're going to switch the x and y. Solve for y. X plus 2 equals 1 over y. You got to have good algebra. To get rid of division, I'm going to multiply each side by y. And so this turns into y times x plus 2 equals 1. And now I can divide away this x plus 2. And I get y equals 1 over x plus 2. Or if I want to use the correct notation, the inverse of g of x is equal to 1 over x plus 2. All right. Moving on, switching the x and y's, inputs and outputs. All right, divide each side by 2. We get y to the third equals x minus 3 over 2. To get rid of something to the third, we take the cubed root of each side. So y is equal to the cubed root of x minus 3 over 2. And really we know this should be a inverse function notation. Hopefully these are pretty simple. If not, you need to touch up on your algebra. Because really, this is just algebra. Everyone can figure out how to switch an x and a y. That is not a difficult concept. And so just look how easy this algebra is for me. It needs to be that easy for you. All right. So notice I'm not really even talking through all of the algebra here. This is a pre-calculus course. After all, I'll talk through this one a little bit more. I'm going to switch them. X equals 7y plus 18 over 2. To get rid of a divide by 2, I multiply each side by 2. So this is 2x equals 7y plus 18. Subtract this 18 on both sides to get 2x minus 18 equals 7y. And now I need to divide away this 7. And y is equal to 2x minus 18 all over 7. And this y is an inverse function, so let's just call it the inverse of g. All right, let's do a little algebra over here now. Switch the x and y. That's a minus 2, plus 2, minus 2 from both sides. X minus 2 equals 4 over negative y minus 2. I'm going to use a little extra space here. To get rid of division, I multiply both sides by negative y minus 2. Negative y minus 2. And so on this side, we get negative y minus 2 times x minus 2 equals 4. Now I can divide away this x minus 2. Get negative y minus 2 equals 4 over x minus 2. Now just solve for y. Negative y equals 4 over x minus 2 plus 2. And I'm going to divide by everything by negative 1. because that's a negative there, which means just flip the sign. We get y equals -4 over x minus 2 minus 2. And just to switch it to inverse function notation is f of x. So we get f to the -1 of x. All right. So if you need this, I'm going to erase it to give myself some space for the bottom. So just pause, 3, 2, 1. All right. So this time we want to find the inverse function, then graph it. This could get a little tricky. All right, so -1 minus 1/5 x. So I'm just going to switch this to x equals -1 minus 1/5 y. I'm going to solve for y. I'm going to add 1 to each side. I get x plus 1 equals -1/5 y. I'm going to multiply both sides by -5 to get rid of this 5 in the denominator here, and also this negative. Hopefully my algebra makes sense to you. Distribute this, we get -5x minus 5. And so now I can graph this equation. I'm going to start at -5. I need to go down 5 over 1. The slope here is -5. It's the same as going in this direction. There we have it. There's the graph of the inverse of x. All right, this one, oh, it's going to be messy. We're going to get a rational function here. So we have a rational function here, right? So the inverse should also be a rational function is my guess. So let's switch them. We get x equals 1 over y minus 1. I'm going to multiply both sides by y minus 1 to get rid of the denominator here. We get y minus 1 times x equals 1. I'm going to divide away this x. So we get y minus 1 equals 1 over x. Add 1 to each side. Y is equal to 1 over x plus 1. All right, to graph this, we really need to know the graph of 1 over x. Well, look, where am I going to have a asymptote here? I'm going to have a vertical asymptote at x equals 0, right? Because x is only in the denominator here. And I'm going to have a horizontal asymptote at y equals 0 because the degree here is 1. The degree here is on the x term is 0, so it's larger in the denominator. So we have something that has this and this. So I'm just graphing 1 over x for now. Okay, so there's a horizontal asymptote and a vertical asymptote. So it's going to look something like this. We're never going to hit the x-axis. I'm trying my best. And we're going to have a horizontal asymptote here. And same thing on this side. Now, but what does this plus 1 do right here? What does this do to the graph? Well, it just shifts it up 1. So really, we're going to shift, I'll just draw the correct graph in black. Shift this whole graph up 1 space. And there we have it. This is the graph of G, the inverse of G. All right, that's everything on inverse functions. So I will see you on section 6, which is